Welcome back, dear students. In this session, I wish to discuss about the order and molecularity of the reaction, the two important kinetic parameters, order and molecularity. First, order. The order is defined as the number of molecules taking part in the rate determining step of a reaction. It is a measure of the number of molecules whose concentration changes as the result of the reaction. Okay, it is the number of the molecules whose concentration changes as the result of the reaction. Usually it is taken as equal to the sum of the powers of the concentration term in the rate expression. Okay, it is mathematically or numerically obtained by adding the sum of the powers of the concentration term in the rate expression, okay, arrived from the experiment. Hence, it is an experimental quantity. So, remember, order of a reaction is always an experimental quantity. That is not at all a theoretical quantity. Next, it may be a number like 1, 2, 3, etc., or a fraction. It is half, 3 by 2, like that, or it may be even 0. Okay, the order of the reaction may be any quantity like a number, fraction, or even 0. Next, molecularity, another important kinetic parameter. That is the molecularity. It is the number of molecules taking part in the elementary step of the reaction, or it is the total number of molecules taking part in the reaction. It is numerically taken as equal to the stoichiometry of the reaction. Okay, that is obtained from the stoichiometry of the reaction. That is from the equation, the sum of the number of molecules in the other reactants in the equation gives the molecularity of the reaction. Hence, it is an empirical or a theoretical quantity. Okay, and it is always an integer. Molecularity is always an integer as against the order. It may be a fraction, 0, or integer, but molecularity is always an integer. Then, differential rate expression of various order. That is for order 0, that is 0 order reaction, A giving products. The rate is always in terms of rate or disappearance of the reactant. Please look into that important aspects. That is, rate is not the rate of the reaction. Okay, for the rate expression, the differential rate expression that I already mentioned, this is the rate of disappearance of any one of the reactants. That is minus dCA by dt now become equal to K into Ca raised to 0. Any number raised to 0 or any quantity raised to 0 is unity. Therefore, minus dCA by dt is equal to a constant K. That is the expression for a differential expression for a 0 order reaction. So, for a 0 order reaction, the differential rate expression is minus dCA by dt is equal to a constant K. Then for first order reaction, n is equal to 1, that is giving A giving products. If we can write the rate of disappearance of A minus dCA by dt is equal to K into Ca, C raised to 1. That is the differential rate expression. That is, the rate now is directly proportional to the first power of the concentration term of the reactant. Minus dCA by dt is equal to K into Ca raised to 1 or K into Ca. For the second order reaction, n is equal to 2, okay, two different types of reaction, that is 2A giving products. We have the rate expression minus dCA by dt is equal to K into Ca square. That is, the rate of the reaction is directly proportional to the second power of the concentration term of the reactant. That is K into Ca, the whole square. Okay. For the second order reaction in which the reactants are of two different types, A plus B giving products, the rate, that is the rate of disappearance of any one of the reactant, that is minus dCA by dt, or is equal to minus dCB by dt. Okay, anyway, it is a rate of disappearance equal to K into Ca into Cb, K Ca into Cb. That is the differential rate expression. For order n is equal to 3, that third order reaction in which the reactants are the same type, 3A giving products, then rate is minus dCA by dt is equal to K into Ca the whole cube. Please see the error. I forgot to type K there. So you please read it as minus dCA by dt is equal to K into Ca the whole cube. That is the rate or disappearance of A is directly proportional to the cube, okay, the third power of the concentration term of the reactants. Then for the different species of A, B and C, 3 different species, molecule A, B and C, we can A plus B plus C giving products. The rate expression is, the differential rate expression is minus dCA by dt is equal to K. Here also an error occurs. That is K into Ca into Cb into Cc. Please you read it as differential rate expression minus dCA by dt is equal to K into Ca into Cb into Cc. That is the differential rate expression. Generally, for the nth order, we can write the rate expression is minus dCA by dt is equal to K into Ca the whole raised to n. Okay, that is all. Thank you very much.